What we're talking about today is drones, or actually, to be more precise, drone. Because this is the one that we will talk about today. And what we will look at code at the end. But on the way to that, we need to define a use case for this. It turned out to be quite important dealing with these drones. And then we'll take a look at how it works, because that will reveal strengths and weaknesses in the platform. And then finally, looking at code, how we realize the use case, and summing things up at the end. And what really qualifies me to be here today is the fact that I am a bit of a spare time nerd. I guess since I was 6, 7 years old, I've been doing the most hopeless things with anything between a rubber band and something running Linux. And this is also why I felt it was such a brilliant idea that we should buy a drone and start doing experiments with this drone a year ago. And in this case, we means me. So we started searching for a drone, which one to buy. And it turned out that this one from DJI Systems was a decent choice. It was actually something you could pay for money, still being serious, and first of all, it has an SDK, so you can do something with it. So we bought this drone, and we downloaded the SDK. Again, we, that means me. And with the SDK, there's a beautiful demo app showing how to control the camera on the drone. And that's it. And I was a bit disappointed. I was hoping to actually control the drone, and now I had an SDK so I could control the camera on the drone. So I contacted the support forum at DJI Systems. I asked if, hey, I was actually hoping to control the drone. Can I do that with the SDK? And they said, well, then you have to apply for SDK level 2. And I said, fine, I hereby apply for SDK level 2. And they told me, no, you need to tell us what you're going to do. We need to see your use case. And you need to send a copy of your passport to us. And I was, okay, I've known you for 2 minutes now, and you ask me to send a copy of my passport to a company in China. I don't think so. So I start Googling for something else. And while I did so, I found this on the internet. It turned out that 2 weeks before, a drone had crashed into the White House. And not only a drone, it was actually my drone. So suddenly it made sense that, okay, the whole use case thing, this is about responsibility. And this is in fact what you were talking about, Søren, and you previously. We want a license plate or something. They actually wanted to be able to identify me if I crashed yet another drone into the White House. Okay, so maybe I did need a use case. The truth was, I just wanted to do some experiments with my drone, but I guess that's not a very decent use case to present to a company that just crashed into the White House. So we need to find something. I think in this sense, it's obvious that location and geolocation is important. I mean, when we're playing with a drone, it happens to be somewhere, and it does somewhere at that position. So location is important. If it was not, it is important. So I stepped back a couple of months back in time. We all want to know where our things are. That's just the way the human mind works. We are location-oriented, and we want to know where our things are. We've been doing this for years, at least 10 years. Maybe 15 years ago, we could mount these things in our cars, if we could afford them. But I guess if we could afford a car that we wanted to track, we could also afford this thing. We had these things in our cars 10, 15 years ago, in our boats. And now we have something we call Internet of Things, connected worlds. We all carry a GPS device and a map in our pocket at all times. So this actually fits very well into now we can really find out where our things are. And we all want to know that, especially if the things are not where we thought they should be. I have two things that I really want to know where are. They look like this. Or actually, very often, they look like this. And when they do so, in a place like this, I really like to know where my things are. So I made the same app as everyone else did. I called it Where's My Kid? I can install this app on 2 phones. It has 2 modes, follow and being followed. So the one app can, well, follow the other app. I could have downloaded this. There are probably 1,000 of these apps in the App Store, but we do things ourselves. So, sorry. So I made this app, and through some magic, the one uploads its position to the cloud, and I can monitor the position on the other phone. And that revealed first scary fact of today. Take a look at these 2 phones. Let's zoom in. They're located right next to each other, but still they claim to be 15 meters apart. I know GPS is not accurate, but Apple claims that they have what they call supported GPS. So they use not only GPS, they use mobile net and Wi-Fi, and still those 2 devices are 15 meters apart. This could be useful information later on. Anyway, it seemed to work okay, my little tracking thing here. So I decided to extend it, or to replace one of the phones, the phone being followed, with a thing like this, which, being torn apart, looks like this. I mounted this in my car, so now I could find out where is my car. And I extended the app with a speed alarm. So if my car suddenly moved where I would not expect it to move, I could get an alarm on the phone. So now my setup looks like this. And just to complete the picture, the cloud service actually happens to be my private server room, which at the same time is my Blu-ray player. So what did we learn from this? We learned basically you cannot trust GPS. And as a side effect, I learned that speed measuring is actually quite difficult. There's so many corner cases you need to take into account here. And the reason why the GPS in our cars are always so precise is the fact that it assumes that you are actually on the road and not beside the road, though the GPS might report so. And it assumes that you have been moving at this speed for the past seconds, so you probably still do so. But actually GPS is not very precise. Anyway, now we have our use case. So, I want to mount this thing on my skier. This reports its location to my Blu-ray player. Me standing on the ground with my phone. I get the location on my phone. I can upload it to the drone, and the drone can follow my skier. That is my use case. I reported that to DJI Systems, and they say, fine, that is indeed an accepted use case. Now you just need to tell me the name of your app. So if any of you are planning to do something like this, just note this, the name I above has been taken now. So, the name, then they wanted an icon for the app. Okay, I made the icon, and this is no joke. Just mark this. If you plan to do experiments with this drone, you have to provide your use case, the name of your app, and an icon. So I gave them that, and they said, fine, now I just need a copy of your passport. I said, no, I'm not giving you a copy of my passport. But I gave them a link to go to Berlin and said, I'm actually part of a team making these conferences. And wouldn't it be great if we could make a talk about drones? And like 2 seconds later, they said, I was approved here. But please note this. You need to prove that you are who you claim to be and provide use case, name, and icon. And what they give you in return is a download link to the SDK level 2. Okay, we have a use case. And how does a drone actually work? Well, how does this thing work? Well, basically it doesn't, because this is a plastic model. But if it was the real thing, how does it work? Well, when the rotor rotates with the blades tilted, of course it produces an updrift. And as it does so, it lifts the helicopter, and if it does so at a vertical line, if the updrift is equally distributed around the circle, we call this collective pitch. Then how does it fly in some direction? Well, most of us think that it just flips the entire circle here. No, it doesn't. Actually,
wash plates with wings at a certain point move forward when they're
exactly.
And
Exactly. It has a little gizmo here under. And every time a blade passes by, the rotation or the tilting of that blade is changed. So that means that the updrift on the circle is not equally distributed when we want to fly in some direction. We call this a cyclic pitch. So we are pitching, and that can be collective or cyclic. Then stupid question number 1 of today. What happens when this thing rotates? Well, because Newton decided some 100 years ago that there should be opposite forces in this situation, the body of the helicopter will start to rotate in the other direction. Which is, of course, why we have the propeller here. So we can keep it stable, or we can actually turn the body if we want to. We call this that the helicopter is yawing. So pitch and yaw. Flying a helicopter is actually not for everyone. The collective pitch you control with the handbrake. The cyclic pitch you control with the joystick. The yawing you control with your feet. And being present at the same time. I can tell it's not for everyone, because that excludes me, and it's definitely not for me. How does a drone work? How do we do these things with a drone? Okay, it's pretty obvious that if we turn all the propellers in the same direction, we will have the thing turning around. So, of course, 2 propellers turning clockwise and the other 2 turning counterclockwise. Then they kind of equal out each other. And the same velocity of all propellers means we have a collective pitch, and it can rise. What if I actually want to fly in some direction? Well, that's pretty easy. I just increase the speed of one propeller. Then what happens? Well, it tilts, but at the same time, I will have more rotation clockwise than counterclockwise. So the thing would start to rotate. So I have to increase the speed of 2 propellers, so they equal out each other. Then it tilts, and it flies away. And if I want it to just fly in one direction, but not increasing the altitude, of course I increase the speed on 2 propellers and decrease the speed on the other 2, so that the combined pitch is kept the same. Then it just tilts and go in one direction. What if I wanted to rotate the yawing here? Well, again, I could just increase the speed of the two propellers turning clockwise. Then the thing would start to turn counterclockwise. But at the same time, it would gain altitude, because now I have increased the combined pitch. So again, I have to increase the speed of two of them, at the same time decrease the speed on the other two. Then it hangs stable and it rotates. So everything is about speed and controlling speed on the motors here. How do we do that? Well, anyone that had a model train as a kid and tried to tune it knows that it's pretty simple. When you apply a voltage to a motor, it starts to turn. And if you apply a higher voltage, it will turn faster. And we could do that here. The problem is that we cannot control this very precisely. First of all, we cannot control the voltage and the speed very precisely. And if we do so, we cannot control it instantly. If I want it to go from one speed to another, it will not happen instantly. It will take time. So when we dismantle this drone here, we see that there are in fact 3 wires on the motor. And this is because these are not conventional motors, what we have here. These are step motors. And a step motor works in this way. I apply a voltage and nothing happens until I apply a pulse on the yellow wire. And that makes the motor move 1 step. In this case, I have 24 steps for an entire revolution. So 1 pulse means that the propeller turns 15 degrees. Or in other words, if I can apply 24 pulses within a minute, the propeller will turn at 1 RPM. Which is probably not enough to fly the thing. The truth is probably closer to 10,000 RPM. So I have to apply like 4,000 pulses per second to the motors. And then the thing flies. And these motors are actually the most important and the main components in this drone. These are the muscles of this drone. If you buy a cheap drone in Toys R Us, you can be sure that it's not equipped with step motors. It's equipped with conventional motors, and it would not be able to fly as stable as this one. This is in fact what you pay for. The rest is just software and sensors. So what sensors does it have? Well, this one has a GPS, it has a compass, it has gyroscope, and it measures the air pressure. And then there's a lot of regulation. Let's see how it flies. Now, before we move on, I'd like you to note 2 things here. First of all, how stable it is. Well, of course it's stable now, because now the movie has stopped. But when it flew, how stable it was. And secondly, take a look at the car behind my holiday home here. On the parking place behind that car, this is where I took off. And when this drone takes off, it notes the position. That is the home position. So if at some point the battery level gets low or the drone gets out of reach, it will return to home, to where it took off. I tried that. It's pretty simple to do that. I just turn off the remote controller, then it loses signal and it comes home. And guess what? It landed on the exact same spot as where it took off. And how is that possible with a GPS that is so inaccurate by nature? Does any of you have any clue how this could happen? Yeah, but even with the gyroscope, you can feel movements, but how could you get to the same spot? No, the truth is actually, it was. Let's see what happened the next time I tried the same thing. Now, when I turn off the remote controller, you can see it goes to a predefined height, which is now the go home position, or the go home height. So now it searches for the home spot. It sets down. Right behind my car. Okay, it seems my rule about GPS is still valid. That position was off by at least 5 meters, maybe 6, 7 meters. But still, when it flew, it was as stable as ever before. It is incredibly stable. I decided to stress test that this summer. On a windy day, I flew with the thing, and it was just as stable as ever before. And to prove that, I built this kite, and I sent the drone up right next to the kite. Let's see how it looks from the drone. Now please note what happens about 2 seconds into the movie here. Oh dear. It caught the tail of the kite. It flipped 360 degrees around. And then it just hung there at the same spot again. Let's see the second part of the movie.
A dangerous experiment.
Yes, it is. But it's not me hanging in the drone filming, it does it itself. It could be a long movie, yeah. Oh. Well, I'm a positive person, so when something like this happens, we need to be constructive. The thing was, well, not very damaged, but at least so damaged that this propeller could not turn at all. So it gave me the chance to make yet another experiment here. I mounted 2 metal plates under the motor and realigned it. So now I have this drone, and there's no chance in the world that this propeller has the same angle and the right position as compared to the other 3. I made this and I tried to fly the thing, and guess what? It was just as stable as ever before. It just hung there. So where does this leave us? What did we learn here? Well, it seems the drone is able to correct based upon the sensor input instantly and at all times. It seems the GPS is as inaccurate as ever before. So chances are that the drone will at any time be very stable at the wrong position. That's actually good knowledge when we want to implement my use case. Before we get to that, there's one more thing we need to establish here. GPS is not very good for determining altitude. Or in fact, it is very good because it gives you the point in space. The problem is you don't know the ground level. You don't know how far above the ground this is. So the drone has an air pressure sensor. And it always takes off at altitude 0. And then everything is measured according to that level using the air pressure sensor. So if I want to get the real position above sea level, I need to know the offset between sea level and where the drone took off. And now some of you may think that using air pressure sensor is not very accurate, and what if the weather changes? Well, this battery has a flying time of 12 minutes. And I think if the weather changes that much over 12 minutes, you shouldn't fly the drone anyway. So it seems to be pretty safe. Let's see how we can control the drone from software then. Again, we first need to establish a couple of things. In the software, you will see the term main controller. And we like to think as the main controller as being this one. It is not. The main controller is inside here. Let's just keep that in mind. That one is the remote controller or the ground station. And not only the main controller is here, there's a Wi-Fi access point in the drone too. And this is what we use. We connect our phone to the access point. So we have and that way we establish the line of contact. Let's see how it works. This is Objective C. I think it should be okay for everyone to follow it. If you think back, yeah, it's pretty bright here, huh? If you think back, when I received I mentioned that I received the link to SDK level 2. With that link, I also received an app key. Every time I start up my app, I have to register the app with this app key. This kind of unlocks the SDK. And if I don't do so, the SDK doesn't work. So again, if you plan to do something like this, where there's no short circuit here, I could give you a copy of my SDK, but you couldn't use it without an app key. So you really have to register and apply for SDK level 2 in order to use the thing. Okay, this is what we do. We make an instance of a drone object. That object is basically our entry point to the main controller and to the camera. We're not going to talk very much about the camera, but you can do everything with the camera. I just printed one example here that you can actually get the live video feed from the camera. You can make still pictures, there are all kinds of filtering settings. This is a GoPro camera. And anything you can do with this kind of thing, you can do with this from software. There's a lot of things you can do with the camera. But with the drone object, we also get a hook to the main controller. And if we register a callback on the main controller and we apply the method start update MC system state, we get callbacks with these system states. And this is where the goodies begin. Take a look at what we get here. Get almost everything about the drone. Its position, well, its home location, not that we can trust it anyway, but we get it. Power level, satellite count, anything. I know the velocity. We have the velocity in 3 dimensions here. So if we want to calculate the combined or the resulting velocity, this is a vector in 3D space that we have to take here. Now, if I want to control the drone, I cannot just set velocity x and it flies in that direction. These are read-only values. So if I want to control the drone, I need to make a software ground station. Good thing is, the main controller actually happens to be a ground station at the same time. So I can cast the main controller to a ground station object, and I can start doing things. On a ground station, or with a ground station, you do tasks. A task is something you want the drone to do. There's one obvious predefined task here, it's called go home. I can actually call this method, and the drone returns home. By the way, you may have asked yourself, why didn't I stop the drone when it crashed when I had it trying to return home in the previous video? Well, the truth is I couldn't. With that firmware, you couldn't interrupt the go home mode. Once it entered go home mode, you could just stand and watch it crash. That has been corrected since then. Also, please note you can set the pitch speed or the yaw speed here. Setting the pitch speed doesn't mean that the drone actually starts to pitch. It's just that when at some point it does pitch, it will be at this speed. On the ground station, you can register a callback too. Now you'll get flying info callbacks or ground station callbacks. This is very much the same as you got with the main controller system state callbacks, which is no big surprise as the main controller and the ground station is in fact the same object. There's a bit more information here, but basically it's the same thing. So 2 entry points to get the same thing. But let's see what we can do with the ground station if we can make a task, a ground station task that actually makes the drone fly. On a ground station task, you can set a lot of numbers here, or parameters. And you can add a waypoint. And a waypoint is a location in space, and this is where the drone flies to. You can actually add a number of waypoints, and then the drone will fly to one after another. You can set the loop property, so it will loop between the waypoints. So this is what I'm going to do to realize my use case. I'm going to use waypoints down the skiing slope. And here is my entire use case on one slide. So what I do is, every time the skier changes position, I note the change in longitude, latitude, and altitude compared to the previous position. Then I take the drone's current position and I apply that change to the drone, and it moves. I make a waypoint, ask the drone to fly to that waypoint, and it moves to that. Then there's an interesting race condition here. It may not have reached the previous waypoint. So I have to remove everything. I don't care about previous waypoints now. I just want it to fly to the new waypoint. On the other hand, if I wanted to fly to the new waypoint based on the location that it just had and it hadn't reached the last waypoint, what do I do? So it may actually come more and more off here, and I still have to test that to see how it actually works. But this is in fact my entire use case that has been implemented with these code lines here. And if you think back on what I mentioned in the beginning, I said that I am a spare time nerd. I didn't say that I'm a spare time designer. So this is how my app ended up look like. So it's pretty simple. I send out the drone. At some point, I press the follow button and the machine starts. Then I have a camera button, and if I press that, it flips to camera view rather than the map view. And now oh surprise, now I have a map button. While I made this use case, DJI invented the new generation of drones. Take a look at the sensors in the new drone. There's been an ultrasonic sensor built in the drone too. So now they actually have collision control. And they claim that you can fly with this indoor. I wouldn't dare to do that with this drone. Based on a compass, an air pressure sensor, in a room with at least 100 smartphones and air condition. I wouldn't do that. They claim you could do that with this. Actually, they say explicitly that you should never fly indoor with this drone I have here. And as explicitly, you can fly indoor with that drone there, the new generation. But with that, there also was an extension to the SDK. Now we have a notion of navigation and mission. They actually implemented my use case at the same time as I did it. I have a follow me mission now. The way it works is if I let the drone go into follow me mission mode, I just keep updating user coordinate and the drone will keep following that coordinate. So there is my entire use case in one code line. Take a look at the Hotpoint mission. With the Hotpoint mission, you can have the drone lock itself at one point and just stay there or do things there. See what you can do here. You can just lock yourself to the position. You can circle around it, and if you circle around it, you can actually set if the drone should keep looking at that point or if it should keep its orientation. So let's see if we can sum this up. What I made here was actually what we 10, 12, maybe 15 years ago called a mashup. If you think back, there was a movement on the internet that we should all open up our data sources, and if we started to do so, the most brilliant new applications would arise. Well, a data source doesn't have to be, well, data from a database or something you can take from an HTTP endpoint. This is, in fact, a data source too. And many of those mashups that we did back then were actually about taking some data and visualizing it on a map. Well, now we can actually be at the position, not just show the position with a drone. And I really think that only our own imagination is the limit here. On the top of my mind, there's something I need to try out here. I want to attach an infrared camera to the drone. Then it can seek its hotpoint by itself. Or imagine if there's been an accident. Send out the drones to get an overview so you know the size of the rescue team that you should send out afterwards. Or here's one of my favorites that I need to do too. It's quite common that we carry one of these, which measures the pulse. I want to do something. If my pulse suddenly disappears, the drone should do something. And I'm not quite sure what it should do. Maybe you should come to me, or maybe you should fly away, because since my heart stopped beating, I don't need it anyway. But I want to do it. And at some point, there will be some maniac trying to make a drone for human transportation. If that maniac happens to be one of you, just think of this. The reason why this works so well and why you can control it instantly is because these propellers have close to weight 0. If this thing should lift me and carry me, I would need something more heavy than this. And I could not control the drone as precisely and instantly as I can now. So one last question here. Is this only something that has to do with the DJI drones? I don't really think so. I don't see that this is rocket science or something that not anyone could do. I would assume that any drone at this price level, which by the way is around $1,000, could do the same thing. So with this talk, I hope I have sown the seeds to some inspiration and shown some of the weaknesses and strengths in this platform. Thanks for being here.
Yeah, there are some questions. What is the reach diameter of the Wi-Fi link? So
800 meters.
800 meters.
Actually, there is, on the remote controller here, there's a repeater here, which extends the reach to 800 meters.
Yes, and then one on the GPS impreciseness. How come that the Amazon can use them then for delivering packages for homes in US?
I'd like to know that too.
Okay, you don't know.
They cannot do it.
They cannot yet? No. Okay. And one last one on legislation. Is it allowed? Are you allowed to use your camera at your home? The video you showed. Is that someone questions the?
I tried to fly the thing back home, where I live in Switzerland, and a police officer came to me and said, "You're not allowed to fly this here. It's a civilized area." That's actually the word he used. You cannot fly it here. But he told me that if I could go out in the middle of nowhere, I could fly the thing. I should just be aware that if a police officer came to me, he could actually claim, or I should be able to at any time show that I have an insurance with a coverage of at least 1 million euros if something should happen. And he could actually ask me to provide this right now, he said, but since he in fact was my neighbor, he wouldn't do that. But there are a lot of regulations about this. Some of them about privacy, some of them just about security. I just read that in Austria, you are only allowed to fly the drone if you have 2 remote controls. You don't have to have redundancy in the drone itself, but you need 2 remote controls. I know in Belgium, you're not allowed to use drones for commercial purposes. There are a lot of these individual rules, which I know the EU is trying to combine. There are talks about you should have helicopter certificates and stuff, and they're trying to figure out there must be a lower limit and how big should the drone be if this and that. There are a lot of regulations. And I'm pretty sure privacy is an issue too. Yeah. Thank you.